Right, so this would be part 2 of how to divide. So previously, we would have learned the very basics of our division. Now, as a reminder, these videos are for our students at Sure Success Tuition. You can call the number on the screen if you are interested in any of our courses, any of our lessons, and we have both online and in person. So let's review how to divide here. We have 75 being divided by 6. So we have learned the long division method. So let's set up the problem using the long division. Remember, we divide digit by digit, starting with the highest value digit. In this case, would be the 7. So 6 goes into 7 how many times? 1 time. We put the 1 directly above the digit we divided. Observe. Good. Now, 1 multiplied by 6 would give us 6. We subtract. We'll have 1. This is the remainder after that division step. 7 was not our last digit. We have the 5, so let's bring down this 5 and continue dividing. 6 into 15 is 2. 2 multiplied by 6 would give us 12. We subtract, we'll have 3. Now, we have no other digit to divide, so putting our answer in a mixed number form, we would have 12 and 3 over 6. However, we should recognize by now that 3 over 6 can be simplified because 3 and 6 have a common factor of 3. 3 can go into 3 1 time, and 3 can go into 6 2 times. So we'd have a simplified fraction of 12 and a half. But we said we want to go a step further. We don't want to just be able to get the mixed number. We want to be able to get the decimal form also. So how do we do that? After dividing the last digit, the ones digit, if there's a remainder, we can put a decimal point. Notice a decimal point in both places. Here, we can add a few zeros. We may need to add extra zeros according to what we are dividing, as we'll see. Now, this remainder of 3, what do? Well, as normal, we continue dividing, but first we bring down the digit. In this case, we added some zeros, so we bring down the 0. And we divide as normal. 6 goes into 30 how many times? 5. We multiply as normal. 5 by 6 is 30. Let's subtract. We have 0. Whenever we reach 0 as the remainder, we have completed dividing. So our answer would be 12.5. Nothing too complicated. So let's try short division fraction notation. So it's the same process, but the format is just different. 6 into 6, 1. 6 into 7, 1. We'll have a remainder of 1, so we put the remainder there 1 time. Now 6 into 15, it's 2, and we will have a remainder of 3. So as normal, we would put our answer 12. The remainder would be the numerator, and the 6 now, which was our divisor, that turns into the denominator. But as we said, this could be simplified, so we have 12 and a half. However, we wanted to be able to have the decimal form also. So instead of putting the remainders of 3 1 time, let's do as in long division. Let's put our decimal points. Let's add a few zeros. And that remainder of 3, let's put it here now. And 6 goes into 30 how many times? 5 times. So we have no remainder remaining. So notice we still get 12.5. So we still got the same answer. You would decide which format is best for you, short division or long division. But my students will have to learn both methods. So let's try this question here. You all try this. 251 divided by 4. Pause the video, give it a try. Great. So now let's work it out long division, set up the problem. Now we know 4 cannot go into 2, so that's 0. Sometimes we skip this step because it's just a waste of time and writing. And we just go 4 into 25 and be done with it. So 4 into 25 is 6. 6 by 4, 24. We subtract, we get 1. What do? We bring down our next digit. So 4 into 11 will be 2. 2 multiplied by 4 would be 8. We subtract as normal. We'll have 3 as our remainder. So this was the final digit. Putting our answer in fractional form as a mixed number, we'd have 62 3/4. However, let's put it in decimal form. What do? Add some decimal points. Add a few zeros. Bring down the 0. Divide as normal. 4 into 30 will give us how much? That will give us 7. 7 multiplied by 4, 28. Let's subtract. We'll have 2. Bring down a 0. Now 4 into 20, 5. 5 fours, 20. Subtract 0. Now we have reached 0 as our remainder. So our division has reached its end. So our answer as a decimal would be 62.75. So let's do short division, fraction notation. Same steps, 4 into 4, 1, 4 into 25, 6. We have a remainder of 1. Now, 4 into 11 is 2. We know now that we had a remainder of 3. So we could keep that in our mind as we put the answer in fractional form. So let's have 62 3/4. Good. However, we don't want fractions only. We want to figure out the decimal form. Again, add 2 decimal points. Add a few zeros. Put your remainder here now. And 4 into 30. Notice it's the same numbers we are getting from the long division step, but many of the calculations are just being done in our heads because these calculations are not complicated calculations. So 4 into 30 is 7. Right? How much would remain? 2. 4 into 20 is 5. So again, we have nothing remaining. We have reached the end of our division. So our answer would be 62.75. So when dividing, we can cancel common factors so that we don't have big numbers to work with. We make it smaller and more manageable. So we have 414 divided by 24. Is there a factor that these two numbers share in common? When we say cancel common factors, obviously 1 does not count because dividing by 1 will just give us back our original problem. So besides 1, what factors do they have in common? That will be easy to divide. Well, for me, I personally, first I looked to divide if 2 is a factor, 5 is a factor, or 10 is a factor. I look at these factors first. And if they are not common factors, well, then I move on. I will try 3, I will try 4, etc. So we're looking at these two numbers. We clearly see that 2 is a factor. So 2 into 24, 12. Let's divide 414 by 2. So 2 into 4, 2. 2 into 1, cannot. Put back the 1. 2 into 14, 7. So 207. Is there another factor that they have in common? Well, yes, we are seeing 3 is a factor in common. So 3 into 12, 4. 3 into 20, we'll have 6. How much remain? 2. Now 3 into 27, we'll have 9. So we have 69 all over 4. Notice we divided first by 2, then by 3. So we could have taken out 6 as a common factor also. We would have arrived at the same spot, but with 1 division step. We could rewrite it just to keep the work neat. And let's continue dividing. We have a smaller division problem. 4 into 4, 1. 4 into 6, 1. Remainder 2. 4 into 29 would be 7. How much would remain? We would have 1 remaining. So keep that in our head and we just put it in the answer. Remember, the final remainder would be the numerator. So our answer in a mixed number form would be 17 1/4. Putting it in decimal form, we add our decimal points. Let's add a few zeros. Put that remainder of 1. And 4 into 10 would be 2. How much would remain? Well, we have 2. 4 into 20 would be 5. Nothing remains, so we have finished dividing. So our answer would be 17.25 as a decimal. There's something we must remember when it comes to decimals. It's something called recurring decimals. So let's see an example with this question. 177 divided by 9. So let's cancel our common factor of 3 first. So 3 into 9 is 3. 3 into 17 is 5, remainder 2. 3 into 27 is 9. So we have a simpler question, 59 divided by 3. So let's do this division. 3 into 3, 1. 3 into 5, 1, remainder 2. 3 into 29 would be 9. And we had a remainder of 2. And so we have 19 2/3 as our fraction. However, let's get the decimal form. Put our decimal points, put a few zeros. Now carry that remainder here to the 0. 3 into 20 would be 6. 6 3s are 18, so 2 remain. So we put the 2. 3 into 20 again. It's the same 20. 6 again. How much would remain? 2. 3 into 20 again is 6. So we could add a few zeros and keep going. But as we would recognize, this would go on forever. So we cannot write 19.66666666 going on forever. So how do we write this as a decimal? Well, we can put 19.6 and put a bar. This bar is called a vinculum over the digit that is recurring. So in this case, the 6 is recurring, so we put the bar over the 6. Let's try a new problem. We have 201 divided by 18. So 18 into 18 is 1. 18 into 20 is 1. How much remain? We have 2 remaining. And now let's see 18 into 21. 1. So we have 11 and 3 all over 18. This could be simplified. 11 and 1/6. Let's turn it now a step further. Take it a step further. Let's get the decimal form. Put our decimal points. Place a few zeros. Carry the remainder here. 18 into 30. 1. How much would remain? 12. So now it's 18 into 120. That would be 6. How much would remain? 12 again. 18 into 120, 6. So like the previous example, we continuously would be having 6, 6, 6, 6, 6 recurring, but we have a 1 before. So our answer would be 11.166666 all the way forever. How do we write this? Well, remember, we put a bar above the digit that recurs. So in this case, it's the 6 that was recurring. So the bar would go above the 6 only, not above the 1. The 1 was not recurring, only the 6. So let's try the question again, a bit different. Let's cancel common factors. So let's cancel the first common factor. So 3 into 18 is 6. 3 into 20 would be 6, remainder 2. 3 into 21 would be 7. So we have a simpler problem. 67 divided by 6. Let's continue. 6 into 6, 1. 6 into 67. Well, 6 into that, 6 is 1. And now 6 into 7 is 1. We have a remainder of 1. So our answer in fractional form would be 11 and 1/6. But let's put it as a decimal. Put our decimal point. Add a few zeros. Carry the remainder this time. Now 6 into 10 would be how much? 1. Remainder, how much? 4. 6 into 40 would be how much? 6. Remainder, how much? 4. Again, 6 into 40. So we notice we have the same answer, right? We will arrive at the same answer even if we cancel the common factors. Once we did everything correct, there were no errors in our calculations, the answer would be the same. So again, how do we write this? 11.16 with the bar over the 6. So just some clarity to understand a bit further where we place these bars. We place the bar above the digits that are repeating. So for example, if we had 1.27272727, we notice that pattern 27, that pattern of digits 27, that is what is repeating. So our bar would go over both the 2 and the 7. This shows that both 27 repeats in that pattern. What about this one? 6.931931. We notice this is repeating. Again, the bar goes above the digits that are repeating. But there's something to note. Instead of using a line above the recurring digits, some regions, they use a dot. So this 1.27272727 recurring would be like this. 1.27, notice we have dots above the 2 and the 7. So it's similar to the bar. Similar here, 6.931931, blah, 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 recurrent. Notice we'd have 3 dots. Or sometimes we might see 6.931. We did not put a dot above the 3 or the digits in the middle if there were multiple digits in the middle. That's on the first digit that was recurring and the last digit that was recurring. So we would use our common sense to know that all those digits would be recurring. The good thing about dividing to get the decimal, sometimes we have a question like this, 3 divided by 4, and so we cannot do that. This cannot be done because 3 is less than 4. You cannot divide. Yes, you can. It is still a division question. You can divide. So let's divide. Pointer 4, 1. Pointer 3, 0. So what do? We put our decimal point. We add a few zeros. Now that's 3. We did nothing with it. So let's put it back as a remainder. Now 4 into 30, 7. How much would remain? 2 would remain. 4 into 20 would be 5. Now nothing remains. So 3 divided by 4 or 3/4 as a decimal would be 0.75.